Okay, here is the lab. I need to submit it before the next class, right? This is just explanation. You can read it afterward. So this is a flow chart in Monte Carlo simulation. You need to sampling and then perform numerical experiment and then estimate the output. So here is the first one. This one is the estimation of pi, actually the same one that I show you in the first, but the first one is 2 pi, right? This is estimation of pi. You need to change it to pi. Right, and just write the code, and then what I asked you to do is to writing R code for this one, and then try it out with different number of iteration from 10 to 100 to 1000, and then see how the estimate of pi improve. Okay, compute the error as well of the pi in that, and then show the log plot of the error as a function of n. Okay, show that the data can be fit to a straight line. Okay, we have 3 questions. Oh, no, that's not questions. All right, that's the first task. The second task is cell simulation. You can say this Jimmy prints neighborhood newspaper with 10 subscribers, right? Meaning that he has 10 subscribers. Sell it to whoever come in front of the lawn on Friday afternoon, right? So there's the demand, paper demand on each week. Observe the pattern here. So what I ask you to do here first is to calculate the probability and the cumulative probability. Okay, number of week. This is the demand. These are the number of week that this number of demand occur. Okay, so calculate probability and cumulative prop first. And if paper costs 30 cents to print and sells at 50, assume that print 20 copies a week. And if they're unsold, we need to throw it away. Simulate the sales for the next 12 weeks with this strategy. That means we would have like week 1 to week 12. And these are the random number that we have. And you need to put in the number of demand for this one, number of sold for this one, number of throw, and the revenue, the cost, and the profit. Revenue comes from number of sold times the price that you sold, right? Cost is the number, the price, the cost that you bought, and the total number that you kind of bought and print out 20 copies, 30 cents for sure. Cost and the profit is the difference between the two, right? The random number here is used in quantile function. I can tell you that. You need to use it quantile function to retrieve this out. Okay, so that's for this one. The last one is I asked you to use the superstore data and then analyze distribution of daily demand on each order, and then analyze time between order, analyze distribution. Seems like there are a lot of things. Let's extend the deadline. Too many things. Let's extend the deadline. Let me check. Let's make it 2 weeks instead of 1 week. Actually, there's a policy. I should not give you a lot of work to do. Make it 2 weeks then. Okay, so you should submit this. You should submit this before April 10. So instead of April 2nd, make it April the 9th of April. So you have 2 weeks to do this. Okay. So the difficult part for the second one would be to actually map from the random number here into the actual distribution. How to do that? You need to have the cumulative probability first. Right? Need to have cumulative probability first. Once you have, so what I asked you to do is to work on quantile function. Right? So say if you want to get the number of demand, what you want is to convert from this random number to the number of demand. So you need to calculate this cumulative value. This cumulative value. And if the value that you have here, 0.41, is less than, is in between, sorry, is in between between this slot and and this slot, right? Kind of between here. Well, let's try a bit of this one. All right. So the probability here is, let's make calculation. Right? Let me, just for an example, I'm going to do this just, right? Okay. Right. So these are the, just for this one, you need to fill all in. These are the probabilities of each of these demands, right? Like this is 1 out of 100 weeks. That means the probability is 0.01. So cumulative probability here is 0.01. And for this one, it would be 0.03, right? It is cumulative. Right? And this one would be 0.07 and 0.16 and 0.26. Now, if you generate random number and then you get the value out equal 0.156, 1562, this is the value that you create. What should be, if you create this one, right? If you remember the second example, we can inverse from the uniform distribution to any types of distribution if you have inverse function. So from this one, we have the probability of this, and then we need to look at which bin should we put in. You can see that 0.1, and if we take a look at the range, the whole range here would have the value from 0 to 1, right? Because cumulative probability have the maximum value here equal 1, right? Value about here would be 1. That means we have 0.1562. That is about here. Because it is less than 0.156, it is less than 0.16, right? 0.15 is less than 0.16, but it is more than 0.07. That means it is belong to this range. That means if you get the value here equal 0.1562, this should be 16, right? The value of all the demand should be 16. So this is how you can convert from probability back to the demand, back to the value here. So the second lab is to work on this one. Okay, we have, right. Okay, and that's for the second one. Okay, don't worry, what I wrote here will be in the video, so you can review it later on. And for the last one, it is quite challenging. This is now to test your skill. You need to analyze distribution of daily demand, analyze the time between order, analyze distribution of order processing time, and then after you get that, simulate this superstore order and processing time. And what I asked you is that is there a relationship between order size and average processing time? Right? You can use the visualization and analyzing distribution to understand that. If there is, what would happen if every Friday the number has been boosted by 50%? Right now, you can perform simulation and see what would happen. That means you need to find out the results. Okay, actually, okay, make it 2 weeks then. 2 weeks to do, yeah. And this is all for today's lecture. Right? We have seen the, yes, please ask the question. Example 4 and the code as well. On which point that you want me to explain? So this example, we want to, I have already explained that, right? You can actually rewatch that. So I would say if you have questions, you can ask about that instead, because otherwise I would just repeat the same thing that you can come back and watch in the video. So which specific point that you want me to answer? Because there will be a video and that you can review it later on as well. Which point? Summaries of everything is like we are going to, okay, got that. Slide number 49. I don't have the slide number here. Which one? Let me check. Slide number 49. Okay, this one. Is this it? Beauty. This one. We want to, okay. We want to, so in order to use Monte Carlo, we need to have certain question that we want to answer. Like what is the chance that the portfolio, the worth, the wealth will be dropped by 10%, right? This is the comparison between the initial wealth and initial wealth, W0, and WT is the projected wealth. And we have this, if it's less than 0.9, then that means the event occur, right? L is the event that it occur. We want to find the probability that this event occur. Okay, so how to do that? Repeat it lots of time. Count the number of times that events occur, and then compute the average, and then you get the probability of this would happen. Okay, so in the code, right? So this is the wealth at time t. It comes from number of A and price of A, number of B and price of B. Okay, divided by at time t, divided by at time 0. If this is less than 0.9, right, you count it as 1. That means that it's a drop more than 10%. If it's more than 0.9, then everything cools, right? You get it's not more than that. And in the code here, the 0.9 is here. Compare the change in the wealth, the change in the wealth with the 0.9. If it's less than 0.9, then we count it as 1, right? If not, then we count it as 0. Okay, actually WT y, actually, sorry, I think this is not right. It's okay, but it's okay, but it's not right. It's not right. Which sense that it's not right? Sorry, I should. What did I need to do? Oh, okay. Sorry. Let me share screen again. Right. This is not right because WT, because of this. So wait for a moment. The reason I say that this is not right because this has to be changed, not to mean, because WT is just one value. WT is just one value. Oh no, WT is a loss of value. W0 is the word at time t. NA, STA. That's the mistake here. STA has to be ST at the time final, right? So this has to be ST at the time t, right? Not the mean of all whole things. This has to be the last value, which is number 1000. Well, it has to be number n. Right, the last location, and then one here. Yeah, it shouldn't be mean. It should be just the conversion from as integer as numeric. Right, it should be like this. Sorry, I forgot that it's not the latest. When you use this as STA here, you get the vector. But what you want is the final value, just the final value, the final price. So here is the final price time NA, final price time NB, and then convert it to number. If it's less than this, that means it will be 1. If not, it will be 0. And then attach it to this. And then repeat it lots of time and calculate the mean. The equation can be manually set up, depends on the objective. Yes, if you want to see if what is the probability of you are actually richer by 20%, you can change it to like this 1.2 and then run it, and we will get the chance of this portfolio get you better at in terms of wealth. You can see that quite good here. You have a chance of 70%, right? Is it true? Yeah, possibly. Chance of drop 1%, 10% by 20%. A chance of getting richer is actually better. Okay. Yes, you can set the equations according to the objective that you want to simulate, right? And there's a change here as well. I will fix the slide and then upload to the group. Fix this one and upload to the group. Okay. So any more questions that you have? Each one of the value in slide 47. Slide 47. This one. Oh, let me change it to this. Right. So what do you want to know? The equations, right? The meaning of the equations in this slide. Start with down here first. This is the Brownian motion. Change of the random walk, change of the current position depend on the previous position plus random, right? So that's for this one. Okay. For this, this is the starting price. The starting price. The price at a certain times can be calculated from this is the exponential here. I think a better explanation would be in terms of so this is the price, right? So the price can increase or decrease, right? Depending on the value can increase or decrease, and this exponential would act like that. If the parenthesis here, if the inside here is positive, then it will increase. If it is negative, then it will decrease. Okay, remember that. Now the first term, we have UA minus sigma square A divided by 2. If the means, the change, is more than, if the mean, the change in the terms of mean, is more than the standard deviation, this is the variance divided by 2, right? It's more than, like, we have a large mean, right? A large means, that means it increased, usually it increased. Right? This is the mean of change. Usually it increase with less variations, then this will be positive, have tendency to increase. If this is positive and comparing to the Brownian motion, still positive, then the price will increase. If this is negative, like mostly go down in this half a year, or projecting to go down in half a year, plus Brownian motion, and is kind of balancing out, it will stay the same. So the equation here indicate the change of the price, right? Whether increase or decrease, depending on the trend and the randomness, right? Is this okay in terms of explanation? Okay, good. All right. Mean of change. Yeah, mean of change. Right, it's the mean of change. I did not put it here. Okay. Parameters here, the mean of change. And the standard deviation of change. Look familiar, right? This one, just like normal distribution, right? But I would say that this is easier to think about it as the change in the because you all know exponential function. It's positive, then it goes up. If it's negative, it goes down. So think about it and then looking at this equation and you will understand. Because it's like I said, if it's positive inside here, the value will be more than 1. If it's negative, it will be less than 1. So better to use exponential here. Is it necessary? There are many models. This is just one of that. And the good thing is that this exponential will scale on the initial value. It means that you can use initial values and then scale it from that point on. Okay. You need something that similar to that. Actually, there are many models like random walk model, regression based that try to do same thing, but depends on modeler. Think of when we talk about data modeling. Modeling is like painting. You are trying to explain the process, create the painting by your own imagination, by your own design. That means you kind of compose this mathematical construct in order to represent something. Right? And this is the representation. And we use simulation. We use the data distribution to perform simulation in this case. Good question that you ask here, like, is it a mean of change? And these are the values that you can estimate from the data. Once you get it from the data, here you can perform estimation. Okay. All right. Now, so let's conclude it here and see you guys next week. The next week we will go into a more exciting topics on machine learning. I will try to not giving you a lot too many assignments. All right. So here's one that is quite good, and I hope you enjoy with this. I learned this first time in my undergrad, in my 3rd year undergrad, and it's quite fun back then. So I think you can play around, see how simulation works, and hopefully you get some ideas to incorporate it into your projects in the future. Okay. So let's call it a day and let's meet together again next week. Right.